our next speaker is going to talk about a global supercomputer. He does a lot of research in data management. He is the director at Microsoft Research Lab in Redmond. Ladies and gentlemen, please welcome Donald Kossmann. Donald, thank you. I was going to make a Microsoft joke there, but I don't think you have anything to do with PowerPoint, so.
Okay, can you hear me? Okay, yeah, thank you very much for having me here. I can actually relate very, very well to the last two speakers. One, I actually did the reverse. I was in academia at ETH Zurich for most of my career, and then I went to the dark side, to industry. So I could talk a lot about his experience, but maybe from the other side round. And I can also relate to Christina's talk because I probably worked for more than 10 years in the building that she was mentioning, and we were always puzzled about these shades. Unfortunately, Christina came too late to my rescue on that one. I can also relate to her talk, of course, because while I was at ETH, I had a Mac, and I was visiting Microsoft, and my Mac always worked, and they were always puzzled how that did. I think in the meantime, it has reversed. Now I have a Windows machine. It seems to be the Macs don't work anymore, but that's okay. So I want to talk about kind of a vision, and I want to start with a graph, or with two graphs that you might have seen, probably prettier. I'm not the best artist, but hopefully the slides will work. And actually, the first time I saw this was from a colleague from ETH, from Friedemann Matern, and it makes absolutely sense. It's the kind of trivial history of computing over the last 50 plus or 70 years. And on the left side, you see computers get smaller and smaller. Right? And Friedemann Matern, he wrote a book about Internet of Things 20 years ago. At that time, it was everybody was puzzled, and now it's kind of like a commodity, that term. And he used that computers get smaller, of course, Moore's law in the density. And on the right side, and this is kind of the inverse of that, is we have more and more computers, right? So 9 billion microcontrollers are produced every year. Your fridge is a computer, and so on. And I'm kind of as the leader of research at Microsoft in Redmond, I'm kind of wondering, how would these curves kind of continue? I mean, they don't look too great. How can they continue? And I'm going to actually put a perspective here to you, and I would I want you to think about what happens if they continue this way. Which means that we end up with only one computer. And this computer actually is not very, very small. It is actually the whole planet. Yeah? And if you know the Hitchhiker's Guide to the Galaxy, that's kind of the vision that was in that book. I mean, if you're a computer scientist, you will use the number 42 everywhere. That comes from that book. And essentially, the mice build the planet as a computer to answer or to find the question of all questions. And 42 is the answer, but they don't know the question. So this is a thought experiment that I would like to do. So the vision that I want to paint here is the whole world is a computer, and it's only one computer. And at the end of the talk, I hope to convince you why this is the right way to think about the future of computing. And for the moment, I'll just give one indication of why this is. And this is just another graph, and that is the network capacity. And that is just going up. And one of the things we do a lot in my lab is 5G research. And actually, as Microsoft, we're now making a very strategic bet. So this will go up and up. And as the world gets smaller and gets more connected, it makes more sense to kind of think of it as one machine. Another kind of example that I typically use here is the car. A car is essentially 100 computers. But for us, it is like one machine. A BMW has 100 computers inside, but we really don't feel them. And this is really how we should think about our planet, as one computer that we don't feel. And of course, we want to program this one planet and work with it as one. The maybe more popular way to look at it, and I'll just give this perspective, is of course we are confronted with cars, with many, many gadgets, with many various forms of cloud. In your home you have a cloud, you probably have one of these disks where you do all your backups. And the way that Microsoft is currently thinking about this scene is what we call the intelligent edge and the intelligent cloud. And the intelligent edge is everything that you have in your home or your company has on campus. And that is, I'm just using the Microsoft brands here. You have that because of security things. You don't want to give everything or compliance to the cloud. You want to have low latency. You don't always want to do the round trip to the cloud. So you essentially use that to do fast decisions, to collect data, and to actuate. And you use the cloud essentially as an infinite resource of computing. And again, what I want to look at that is, let's just look at this whole thing. Let's not divide anymore between intelligent edge and intelligent cloud. Just look at it as one big machine, just like we look at a car at one big machine. And just to give this perspective on this, there's an external perspective, and that's really the one that I find most interesting. And if you look at it at one machine, you want to program it. We had this morning a talk about climate change. Of course, I would love to write a small program that says, well, if carbon footprint is larger than X, set carbon footprint to Y, right? Something very much lower. Of course, this is not going to happen, but if we want to solve these very, very big problems, we essentially want to program the planet. Yeah? We want to see, and in some sense, this is exactly what was done in this talk this morning. It was, in some sense, a programming of the planet. Of course, there's also this internal perspective. This is the internal perspective that I kind of deal with in my day job every day. And this is just like the car, like the BMW mechanic, right? Will open up the hood and will look inside and then will fix individual components that are broken. But for most part, I mean, and of course that perspective is necessary to keep things going. But I think the external perspective is the one that, for example, my grandmother also would be more interested in. So this is the vision, and I think it, well, in some sense it sounds trivial, but the thing that I ask myself is, well, how is that going to impact? How does this now give rise to innovation, and why is this happening? And essentially the 4 questions that I usually ask myself is, well, if we now have this whole planet as one big machine with billions of microprocessors and all these storage systems and a huge network, it's heterogeneous, but it's all connected in some way. So what can you do with this machine that you cannot do today? And that's actually a pretty hard question to answer. And I'll give a small example that we developed in the lab, but essentially shows you how, where things are going and how this mindset of programming a big system or programming the planet could go. What I will talk mostly about is how this actually changes, and this mindset will change the whole IT industry. It has changed it already, but there's a more fundamental thing. And I think there are also other industries that are kind of beginning to think or kind of be disrupted or kind of rethink their assumptions. And there's a big assumption here or new assumption here, and I'll get into that. Now, 2 things that I will not talk about because it's just too limited is the security aspect. I think everybody cares a lot about this in this hyper-connected world. If everything is connected, we still want to draw lines, right? We want to protect our privacy, which is drawing a line around my sphere. I will not talk about that, but of course this is a huge topic for us as a lab to do research in, and then of course bring those things into product. And the fourth thing, the final thing is, how do you program it? What are the new, how do you do that productively? The slogan that I'll show at the end of the slide is really the way I think is, make the world programmable and make everybody a programmer. And that's essentially what I see as the mission of my research lab. And I will not talk about that either, because that, again, has many, many facets. So let me just give you one example of how to program the world. So this is This is a Microsoft marketing slide, so you don't have to understand it, but I'm going to tell you the story of this picture. And you can see there's a lot of tech here, right? A lot of things going on. But the story is actually pretty simple. This is agriculture, and there's a trend since the 70s in agriculture, which is called precision agriculture. And you can think of it as it's the equivalent to, in healthcare, personalized medicine or precision medicine, where everybody kind of gets treatments and, that are personalized to their particular thing. So if you are older or younger or so, you will get specialized treatment. The same is true for agriculture, depending on the state of your field. Right? The humidity, how many bugs there are. You would grow different crops, and you would do different treatments to your field. And the theory of that has been studied, again, since 70s, more than 40 years, probably even more than 50 years, and it's well understood how to do that. What is the problem? The problem is you don't know the state of your field. You don't know which bugs are there. You don't know the humidity. You don't know exactly what is going on in every corner of your field. And of course, there are sensors to do that. There are bug sensors, there are humidity sensors, there's all sorts of stuff out there. But unfortunately, these sensors are super, super expensive. Well, not super, super expensive, but at scale and the dimensions we need for these fields, it's just not economically viable. And this is why this idea has never taken off. Well, fast forward into 2020, and the research that we've been doing at Microsoft in our lab, and actually I just heard this morning that the first farm in Switzerland is actually using this technology to do precision agriculture. Essentially, we don't use these sensors, these expensive sensors. We have one sensor, and that sensor is a drone with a camera, and it just flies over the field and takes pictures of the field. And then we have the whole machinery of AI, and that's why I call it the global AI supercomputer, and the connectivity to the cloud, to the hub of the farmer, to interpret the pictures, to learn from the pictures, from all that, to infer the state of the field, and from that and all the experiences that we have with other, and the models we have from precision agriculture, to recommend the best crop and the best treatment of that field. And for me, this is a typical example of very highly distributed with very different things. There's the drone, there are the actuators. I visited last year the Urbana-Champaign, which is in Illinois, huge agricultural school. And they actually are now developing robots. They have the drones flying, and they're now developing robots that disseminate pesticides into the field. And you see how many different components, but at the end, from the farmer's perspective, this is one machine. This is one system, and they want to interact with it on their phone or at their home on their laptop, and they want to interact it in a uniform way, and they don't even want to be aware that there's a drone. Well, maybe they have to be aware when the drone crashes or is hit by some or stolen by some children, but to large approximation, they want to think of it as just the world as one thing that they want to program. So this is kind of why this is just the thing. So what I would like to go at is how this kind of thinking, how it is changing the industry, or it's beginning to change the industry, but also how we think about one aspect, and I'll talk about efficiency. And it turns out that with all these things, security and creating new value through new applications, efficiency is still one of the things that is driving this industry pretty much and pretty big. So if we have this whole world as one big machine, of course composed of many, many small machines, what is an efficient? How do we make that sustainable? At this point, data centers actually consume more energy than I think the airline industry, and that was even pre-COVID. Of course, now with COVID, it's kind of off the roof how we burn calories on this planet, and the airlines a little bit less. But it shows that we really have to think about it. And at Microsoft, of course, we have this negative carbon footprint initiative, and we want to be negative carbon footprint by 2030, and by 2050, we will have eliminated all the carbon, that's the plan, that we have done. So what is an efficient machine, if we now think of the world as an efficient machine? So an efficient machine has two properties. The first property is that it has low unit cost. Yeah? So the typical example that I do, I'm a slow reader, right? So I read maybe a page in 5 minutes of a book. And my wife, she is actually a fast reader. She reads a page in 2 minutes. So she's clearly a more efficient reading machine than I am. If you think about computers, right, or any machine, is the more the computer does in a lower amount of time, it's more efficient. And most of computer science and most of the history of the IT industry, in particular where I am, has been focusing on that and making that better. Yeah? But there's another aspect about a machine to be efficient, and that it needs to have high utilization. If you look into your pocket, you have a computer, and that is an iPhone or an Android phone. If it is a Windows phone, be happy. I actually loved the Windows phone in its days, but I don't have that anymore. But if you really think about it, it's a very efficient machine. It has low unit cost, but it has super low utilization. And it is, in the way it is packaged, it's shipped, it's fundamental to that phone that it has low utilization. I would be surprised if you have more than 10% utilization. Yeah, at the moment, you might be even doing something with it, but the processor is so strong. The storage, probably, I don't know how many photos you have on it, but even the storage, you will never max out the storage on that machine because it will overflow, and then you take a new picture and it will tell you you can't do that. So these two things are the things, if you want to be efficient, you have to achieve both. And I'll just give a list of things that you do to achieve one and the other. So this is the list. If you want to decrease unit cost, what you essentially do, philosophically, is you aggregate resources. That's exactly what your phone does. Your phone is a CPU, its processor, its storage, its communication in one box, put together. Yeah? And that makes it have low unit cost. That makes it efficient, that when you click on it, you will immediately get an answer because you don't have to get those resources together. They are pre-provisioned for you. It also does this provisioning of these resources in a coarse-grained way. You do it when you buy it, and it stays, that phone, and these resources stay together until you dump it on, you throw it on the floor, or what my children like to do is they throw it into the bathtub, and then it breaks. So this is a very coarse-grained provisioning. And again, because of that, you don't have to think about it. That's what you get. That's what achieves the low unit cost. It's also very specialized. You might have heard of Moore's Law and the end of Moore's Law. What we're doing now is we're producing accelerators. Your phone has a GPU in it just for the graphics of the screen. If your phone, even if you telephone and your screen is off, you don't use that GPU, right? It's not utilized, but it's good. Yeah? You co-design, you do deep levels. If you're an engineer, you will understand what I'm saying here. You optimize the whole thing. This is why Apple was so successful. They put everything together and they optimized everything together, and of course, they created all these layers and a deep integration of the experience. Now, if you want to increase utilization, you do exactly the opposite. Exactly the opposite. You disaggregate. Right? You take, and this is in some sense what the cloud does today. If I need a GPU, yeah, I don't buy a GPU. If I need a GPU, I rent it for the moment I need it, right? That would be ridiculous on your iPhone, but it is how many big systems are operating today. You will rent for a few seconds, so you do the provisioning in a very fine-grained, short way. You just rent something for the time that you use it. You make sure that all the resources that you have are fungible. We at Microsoft, when we talk about the cloud, we really think carefully about what are the machines that we provision. Yeah? And we don't want to have like every machine possible on the planet and put it into the cloud. We want to have just a few sets of machines, but they should be very fungible, meaning that any machine can do anything. And then, of course, you decouple, and this is another buzzword of the industry in mini-services as you go along. Okay, as you can see, the two goals are in the exact opposite. And the message that I would like to drive home, again, in the context of the global supercomputer, and I'll try to do that, is that this is actually driving a big transformation of how the whole science and engineering of computers is done today, and why this also fits into the thing. So this is an opportunity, and my hypothesis is, and this is where I kind of eliminate most of my research that I did at ETH, is that in order to get both of them, you actually have to pivot for the utilization. So you build a system or a machine that works well for high utilization, and then you optimize it to decrease unit cost. And this is, again, this is the exact opposite how this industry has been moving. In particular, how you have been moving with buying PCs, buying smartphones, buying even your car, right? Your car is also a machine that was optimized for low unit cost and not for utilization. And I want to give an analogy of a different industry. And the industry I want to give is retail. And it's maybe not surprising, but I just hinted at mobility. It's probably most industries today are kind of going to have this shift. And they're also going to have this shift of thinking much more globally at scale to get the utilization. So this is a shopping mall, or as we call it, this is called brick and mortar retail. And obviously this shopping mall is the old world. And that is the old world of optimizing, aggregating resources. So all of these shops, you can see a Gap shop there, you can see a Nike shop somewhere there, is like your phone. It has aggregated all the resources. It has a cashier. It has storage. It has people who make recommendations. All the services of a shop are kind of aggregated there together. And of course, that provides a very unique experience for you, the low unit cost. You know, when you go into the Nike store, you're going to get what you want, and it's going to be as efficient as it gets. You walk in there, and you get your things out. And here is kind of the breakdown of, in retail, how it works. So why are you doing that? So what is happening here, really, in the engineering sense? What is happening here is that you move the app, in this case the shopper, you move it to the data, which is the shop. And then you have the online world, which is the exact opposite, where essentially you stay put, and the data, the goods, your shoes, they come from the shop to you. Right? It's the exact opposite. That's the online world. And you can go through this, and you can go through all the technical implications that this has in a shop, and you can mirror them, and you can go through the implications that this has for the IT industry. So I'm just mentioning a few others here, like the data. In the brick and mortar, the data is partitioned logically. You have a Nike store. You have a Gap store, right? That partitions your data. Your shoes, the Nike shoes, will go into the Nike store. The Gap clothes will go into the Gap store. If you look at Amazon, they don't think like that, right? They don't say, oh, I have a warehouse for all Nike shoes, and I have a warehouse for all Gap clothes. No, this is all muddled together, and you might have a bin with a certain pair of Nike shoes, and next to it you might have some Gap t-shirts, and then you have something totally different somewhere else. And I will explain, of course, it took Amazon 20 years to get that right, because there's complexity, but I'll show you the trends that go to that. When you think about brick and mortar, it's optimized for low latency. You want to be served immediately. The online world is optimized for throughput. You're not going to be served immediately. Even with same-day delivery or two-day delivery, there's going to be a lag. Right? Of course, with films also, it's a little bit differently. There you can get it immediately if you have digital goods. But in the normal goods, there is a delay. But for very high throughput, for scalability, which means at the end for low cost. The granularity of decisions. When you go to a shop, I say, oh, I'm going to go to the Nike shop. If you go to Amazon, you jump around very different things while you're on the website. You're navigating the net. So your granularity of decisions, or going back to what I said before, the provisioning of resources is very fine-grained versus too coarse-grained. And I'm just putting this red at the bottom to reflect a little bit, again, philosophically, to get you thinking. The old world was customer is king. What was this about? Advertisement was about getting customers into the Nike store. In the new world, the platform is king. You go to the platform, which has everything. It's Nike, and then the platform essentially tells you what to do. And in the old world, it was kind of you as a person had to design your tour. Oh, I go first to the Nike store, then I'm going to go to the bakery, then I'm going to go there. And you could do that because that was kind of, you had 5 or 6 errands that you had to do, and you somehow sorted it out. In the new world, what is happening, Amazon is essentially saying, tell me what you need, and I'm going to somehow put it together, and I'm going to do the optimization transparently to you. Yeah? Again, think about the global AI supercomputer. The farmer says what the farmer wants, says, okay, milk it's a good year for milk, prices are up, produce some milk. And then the system, the drones will go flying out, and they will find out which crop to do, how to feed the cows, how to insemin the cows, and so on. It's under the cover. That's the global AI supercomputer. So here are the trends. We all know that we need both. There are many applications or many scenarios, right? You're invited to a wedding tomorrow. Oh, it's too late to order online. It's too risky. So brick and mortar is not going to go away. You also want to have a special touch and feel, and we're still not there yet that you can really see with avatars how a dress will look on you. So you need that. But the trend is really going towards the online world. And why is that? Because there are some very big trends. The one is the customer preference. Actually, the latency is not what customers care most about. It's the cost. And the same is true for the IT industry, and that's what I'm trying to say. And the other thing is the intelligence. The customer knows best. Here's a little bit of a itchy thing. Now, the fleet knows best. The army of customers, the horde of customers knows best. That's where big data and AI technologies come. And actually, we're pretty happy with that. Otherwise, companies like Google and Facebook wouldn't be so successful if this was not true. Right? And the third thing is logistics. Actually, people are, I live in the US now. It's actually really hard to get to a shopping mall because the traffic is so terrible. Of course, COVID helped there, but then it also, the shops were closed. So also the logistics are actually going into the favor. And this is happening in retail, and it's happening in the IT industry as well. And that's what I want you to think about. And if you want to kind of go back to the global theme, the right world is the global theme. That's the global AI supercomputer. That's the global shop. It's the same analogy. And if you want to think in other industries, health and mobility, energy, I haven't really thought it through, but I'm pretty sure you will see similar trends also driven by efficiency and by the way the world gets closer and closer together. So these are kind of technical trends, but I see that I've already eaten up most of my time, and we might want to have a question. But there's also some very specific technical trends, and maybe we can go through them in the questions, like really hardware trends, security trends that actually go and drive into that direction. And with that, I want to close. We are really going towards a world where we look at the whole planet to be one big machine. And the vision essentially is, make this world programmable. We want to program the world. We want to program our lives. And we want this to be as efficient as possible. And of course, there's a second annotation to that, which we call the democratization, is we want to make everybody a programmer. And I think this is going to raise huge opportunities, not only for the big companies, but that's why I'm saying this. Now, if we're all part of this big machine, this is not owned by anybody, right? And in particular for Switzerland, and I know that small KMUs, small, medium-sized businesses are a big theme of here. Think of how you kind of relate, how you sit on that platform, just as you thought about how you relate to a PC as a platform or a smartphone as a platform. Think of this as the new platform that you will make business on and optimize your life on. So thank you very much, and I think we still have a little bit of time for questions.
We've got a little something physical for the supercomputer there for you. You know, yeah. I thought that was an interesting statement there, that the customer used to be king and now it's the platform, right? So if we, you know, in the current discussion that you have, if you replace customer and let's say, you know, platform with something like Amazon, that raises some interesting questions, right? Because the customer used to be king, and now Amazon is king, which is odd because you're seeing a lot more of this antitrust sort of situation. So I wonder what's going to happen in that regard, because as you said, it makes sense to summarize these things and to consolidate, but it does create a whole bunch of different problems. So we have time for one or two questions. I'd like to open it up to the field. So, what that's a good question.
Yeah, the question was, what is the operating system? And so actually, this is exactly the kind of question we're thinking about, and what are the right abstractions. It turns out that there's a simple abstraction that we cannot even make sense out here. You're a computer scientist, you know, on your PC you have something that is called a process, right? When you call a program, you start a process and that executes it. What is the notion? And of course, the process, it kind of relates. We have to reinvent all of these abstractions. We tend to think of this as an experience. What is a process is now an experience. But we really have to formalize that in a better way, and we haven't done that. Yeah, that's why there's also research opportunity here.
That was a great research answer, because I was expecting to hear just one Windows. You know, that's what I was expecting.
Yeah, well, yeah, we're...
Windows 20, Windows 20. Perfect. Guys, thank you. You'll be around for some questions if anybody has any afterwards, right? So, guys, big round of applause. Donald, thank you for being here.
Thank you.